All right, so this is 18. So this is in the synthetic division section, but it says determine whether each binomial is a factor. So real quick, side note, ignore 18 for a second. So if I were to do let's do 15 divided by 3. Start over. Sorry. All right, so forget I said anything. Now that you have a clean, fresh mind, is 3 a factor of 15? And hopefully you said yes. 3 times 5 gives us 15, so yeah, 3 is a factor of 15, because we know our multiplication tables. But let's say we didn't know our multiplication tables, and I tried to divide 3 into 15. All right, 3 can't fit into 1, so 3 fits into 15, and I guess it fits 5 times, and then I do 3 times 5, right? And there is no remainder. Now, is 3 a factor of 17? So if I see if it fits, I'll try. It fits maybe 5 times, so I do that, and I have a remainder of 2. So 3 fits into 17, 5 and 2/3 times, right? So it's not a factor of 17. And there was a remainder, okay? And we could look at many numbers and see, and it doesn't have to be 3, I'm just on a roll with 3s here, right? If there's no remainder, it's a factor. All right, so 18, determine whether each binomial is a factor of this guy. So what I'm going to do is I'm going to do synthetic division, right? So I'm going to take 2. Oops, sorry, I'm in the mode of long division. I'm going to take 2, and I'm going to see if it fits into 1, negative 10, 8. So I bring down the 1, multiply by 2, that gives me 3, right? 2 times 3 is 6. That gives me negative 4 times 2 is negative 8. And so I'm left with, well, there's no remainder, so determine whether, so yes, it is a factor. So x minus 2 multiplies by x squared plus 3x minus 4 to give us this guy right here, right? So there's no remainder, so we know it's a factor, and we know that it'll multiply by the quotient that we got when we divided. So the quotient's the answer to when you divide, right? So that quotient multiplies by x minus 2 to create x cubed plus x squared minus 10x plus 8. Now, just real quick, we could factor x squared plus 3x minus 4. So think, what multiplies to give you negative 4 but adds to give you 3? Agreed? Yeah, it does work, right? And so we're going to see these are the factors of that guy, and x minus 4 is not. You can do synthetic division real quick if you wanted to, and you'll also see that there is a remainder, so 18 is not going to work there. All right, so then you asked about 24. Oops, sorry, wrong way. 24, here we go. And sorry about the formatting. I typed it up, and then apparently when I changed it to a PDF, it did not work so well. So you're right, there are 1, 2, 3, 4, 5, 6, 7 points. So you're right, it would be a 6th degree if we followed that rule. But if you remember on the homework, 8 and 9, I said decide which is better. So think back to the homework that you did, and numbers 8 and numbers 9, I said decide if you would use a I said a cubic or a quartic, if you can remember that. And the calculator ended up using, we found out which one was the best. I don't know if you remember looking at that. So what I would do is I would start with a quartic, and I would see how well it fits. Just look at the graph. If you remember, we could store that. And if you don't know what I'm talking about, just send me an email, and I'll hurry and make a video for that. But I would store it and see which one works best. I would do it with you right now, but I'm on my iPad, because then I can write instead of my laptop. And so if you go to stat on my, it won't let me show it to you because I have the free version. And so if you do need help on seeing if the quartic will be a good fit, if it kind of follows those points, just let me know, and I'll do that on my laptop. But if not, then you're good. All right, and then let's see real quick. Oh yeah, 26, part B. Okay, use cubic to model the data below. Let x be the number of years after 2000. And again, I'm sorry, I haven't made the key for this yet. So I'm going to hurry. You can fast forward and wait till you see me write. But I'm going to hurry and put that in. I haven't done it yet, so sorry you don't get a watch, but it's not too fun watching somebody plug things into the calculator anyways. Oh, but what I did want to do, if you look back at A, I want to just make sure, so grab your calculator if the data is still in there, and hit stat and go to edit, and make sure your list 1, so let x be the number of years after 2000, so 2004 will just be 4, 7, 9, 10. Just double check your x list, and see if that might have been a problem, but I'll tell you in a second. And then 457 for our y's, 9, 10. Okay, and then let me hurry and calculate cubic. Okay, so just double check, your model was y equals negative 5.9x cubed plus 120.5x squared minus 629.2726, repeating really, x plus 1421, and this is actually a really good model. It fits it really well, the cubic does. So I know that it is a good fit. Now we just gotta, okay, you want to know about, yeah, so you're right, you could just go, if you stored that, I did not store it, so give me a second, sorry, I gotta hurry and store it. Cubic regression, oh yeah, sorry, great. Okay, so I'm going to plug that in. And make sure you're plugging in an 8, right? Just, I'm sure you are, but just a reminder. And it should, as long as you typed everything in and got that same equation, it should be good. The population is growing quick. Okay, so I got, let's see. Oh yeah, you're right, it doesn't really seem right. You got a lot lower. So I got 1078.04. So yeah, not positive what happened on yours there, but double check that. And if you remember, we're not actually doing rate of change, so you can skip those. So hopefully this helped. If not, just email me.